Today's video is going to be on the relationship between cosine and sine. So we're going to start by reviewing just what those relationships are. Remember, it's always the trig function of the angle is equal to the ratio. So sine is the opposite side over the hypotenuse. Cosine of the angle, and that's your reference angle, is the adjacent side over the hypotenuse. And the tangent of the angle is the opposite over the adjacent. So in our first example here, we have our triangle COW, C-O-W. We've got a right angle 37 degrees, 53 degrees, 12, 15, and then our unknown side over here, we want the sine, cosine, tangent of angle W and angle C. Don't forget that we only take the sine of the acute angles. That's why it never asks for the sine, cosine, tangent of angle O, because that's our right angle. But we do need to find this missing piece, and remember, anytime you have two of your three sides of your triangle, we can find the third side by using Pythagorean theorem. So 12 squared plus our missing side of OC squared is equal to 15 squared. That's 144, plus OC squared is equal to 225. We move the 144 over, giving us 81. We square root, and we find that that missing side is going to be 9. So when we start our trig functions, we've got sine of W. Sine is the opposite side, so 9 over the hypotenuse of 15. We always reduce our fractions if we can. 9 over 15 can both be divided by 3, so that reduces down to 3 over 5. Cosine of W, so here's again our reference angle W. Cosine is adjacent, which is going to be 12, over the hypotenuse of 15. Both of those can also be divided by 3, so 12 divided by 3 is 4 over 5. The tangent of W, so here's again W is my reference angle. Tangent is opposite over adjacent, giving us 9 over 12. Reduce all those by 3, giving us 3 over 4. Tangent of W. So for the next row, we're going to switch reference angles. So instead of referring to angle W, we're going to go from C. So sine is opposite over hypotenuse, giving us 12 over 15, reducing down to 4 over 5. Cosine is adjacent. So if here's angle C, the adjacent side is 9 over 15, reducing down to 3 over 5. And tangent of C, so from angle C, we want opposite over adjacent, 12 over 9, which is reducing down to 4 over 3. So we found our 6 trig functions. We can see from above that we're going to look at what angle of what. So sine of angle W, if I look at sine of angle W, which is 3/5, that's going to be equal to cosine, not cosine of angle W, that's 3/5 and that's 4/5. But the sine of angle W is equal to the cosine of angle C. We see that the cosine of W, which is 4/5, is equal to the sine of angle C. So why is that? When I look there, sine of W is opposite over hypotenuse, and the opposite of W is 9. Well, opposite of W is the same side that is adjacent to angle C. That's why sine of W is equal to cosine of C. We're referencing the 9 over the 15. 9 is opposite of W, giving me sine of W. And 9 is adjacent to C, which is why it's cosine of C. So the side opposite is the side that is adjacent to C. That's why your ratios are going to be the same. So it says, look at the acute angles in your triangle above. What do you notice about the relationship between those two angles? So if I look at these two angles here, we've got angle 37 and angle 53. It said the acute angles. So if we look at 37 and 53, it just so happens that 37 and 53 add up to 90, which means that they are complementary. Remember, supplementary and complementary. Supplementary adds up to 180. Complementary means that they're going to add up to 90. So therefore, if I tell you in a different triangle, so not the triangle that we're looking at right now, but if I tell you angle C is 30 degrees, then you know that angle W has to be 60. Because if those two acute angles have to be complementary, 90 minus 30 is going to give us that 60 degrees. We're going to use that idea to solve these ratios. So the sine of one acute angle is going to be equal to the cosine of the other. So I have to switch angles and switch trig functions. When I switch angles and I switch trig functions, those ratios are equal. But we just talked about as well, I know that the two acute angles in a triangle, right triangle, have to be complementary. So if this is 62, then this has to be 90 minus 62, so x has to be 28 degrees. Another way you can look at this is 62 plus x has to be equal to 90. So you can also set up a different equation, and then we move that 62 over, and we find the same answer that x is going to be 28 degrees. So if we go to the next one, if this is 40, that means that this whole angle right here has to be 50 degrees, because remember those two have to add up to 90, which means x plus 22 has to equal 50. We move 22 over, and we find x is going to be equal to 28. Now, you also could have set up another equation, 40 plus x plus 22 is equal to 90. I know that this and this have to be complementary, so added together they have to equal 90. And that gives me x plus 62 equals 90. Move our 62 over, and we find that x is going to be 28, that same exact answer. So it doesn't matter which way you set up your equation there, knowing that they equal 90, so you can easily find that second missing angle. Where it gets a little tricky is when we get to number 3, I don't know angle A or angle B. I don't know either of my acute angles, but I do know that these two angles have to be complementary. So I know that this angle plus the other acute angle has to equal 90. So in 1 or 2, you had two different ways you could solve this. For number 3, there's only one way we can set this up. We know that the two angles have to add up to 90. Combine our like terms, 1x and 3x is 4x. Negative 5 and 50 is going to be a positive 45. We move the 45 over. 4x equals 45. We divide by 4. And we find that x is going to be 11.25. All right, so a lot of different relationships we talked about today. Just remember that as we look at our triangle, the two acute angles have to be complementary. They have to add up to 180. And the sine of one acute angle is going to be equal to the cosine of the other. The ratios are going to be the same. All right, and then that concludes our video for today.